Hello and welcome to the fourth video in this little lecture series. In the past video we talked about variables and in particular booleans and how they can be used with conditional if statements. And in this lecture we're going to talk about some more bits of what we refer to as conditional logic. So we've seen some stuff like x is less than y, x is greater than y, x is greater than equal to y. And so we're going to expand some of those statements that we can essentially ask about relationships between variables, like saying, x is equal to y and a is equal to b, or something of the sort, ands, ors, negating things, so demanding that something is not something else, and so all sorts of things and the symbols associated with those. And so let's just review real quick. So see, we have here in our program, we're setting two ints, x and y, respectively, to the values of 8 and 5. And we're saying if x is less than or equal to y, then print out x is less than or equal to y. And then after that happens, if x is greater than y, print out x is greater than y, which is pretty intuitive. And since these x is less than or equal to y, if something is not less than or equal to something else, then it is greater than that thing. So basically one of these is going to happen, but it is impossible that both should happen. So I'll just see that run real quick. And we see that since x is greater than y, 8 is greater than 5, it is the second one that runs here. Okay. Oh, the other thing I forgot to talk about is comments. So in essentially all programming languages, there's a type of text you can write called comments, which is a specified section of code that is not read by the computer, but simply serves so that you can make little notes or annotations to either yourself for when you're looking back at things, or to someone else that's looking at your code and trying to collaborate with you. Especially in collaborative projects or in big companies when you have hundreds of employees and programmers working on projects that are millions of lines long. It's really important that code has comments so that if you need to go and look at someone else's stuff, that you can sort of follow along and use it as a kind of spark notes of the code so that you can see exactly what's going on and have some comments outside the code in case it's not quite apparent what they're doing. And so in Java, the tag for the comment is a double slash like this. And when you do that double slash, you'll see the text turn green. And so I can type anything I want here. And it doesn't matter. So Eclipse doesn't care about anything I type here. And as Java reads down, it will say, okay, well, here's this command. Oh, here's some comments. I can ignore the rest of this line. Okay, go to the next line. Keep going down the line. And so generally you would tab over one or two bits and you can, type more stuff here. But more practically, we could say something like, we take an integer x and set it to a value. And here, we take an integer y and set it to a value. Something like that. And so through these lectures, I'll be using comments to sort of annotate the code and show and sort of serve as reminders of what these things are doing. So in case you're wondering about what a line does, in case I'm not talking explicitly about it at that point, you should look up and possibly see the comment and get some information and figure it out from there as well. Okay, so I'm going to get rid of one of these statements, and we're just going to deal with one if statement at a time. So we've looked at less than. We've looked at greater than. We've looked at less than or equal to. We've looked at greater than. Whoops. Greater than or equal to. And that's what we've looked at so far. We have not looked at equal to yet. And what we'll find is that it's not going to be as simple as saying, well, I mean, it's not that it's complicated, but it's not going to be saying if x is equal to y. We see this strange red underline. It said type mismatch, cannot convert from int to boolean. So what the heck does that mean? It means that in Java, when we use a single equal sign, we're basically saying that whatever is on the left hand side of this single equal sign is going to assume the value of whatever is on the right. So we're saying, okay, here's an int called y. Now, by the power of Java, that int called y is going to hold the value of 5, which is on the right. And it is not commutative either, like it might be in math. You can't say 5 equals int y. No. It just doesn't know what to do with that. You'd be trying to like make a new variable and insert that into a number, which makes 0 sense. So these single equal signs in Java are not commutative. It is a very specific, take some particular variable, and we're going to insert and update it with the value of whatever is on the right hand side. So if we wish to get a Boolean value, because remember, whatever is in here needs to eventually turn out to be either a true or a false. And so why it's yelling at us, cannot convert from int to Boolean, it's saying that we're dealing with integers in here, and it can't figure out a true or false from that. And so what we need to do is use two equal signs. And that's just something that is syntactical in Java, and that's how it is in most programming languages. Not all, but most. And so a double equals is equal to. And so if I say x double equals y, that will return either true or false, depending on whether x equals y. So in this case, so I've set this up so that if x and y are equal to each other, it'll print out x equals y. But it is not the case that x equals y. So if I run this, nothing happens. But if I make them equal to each other, 5 is equal to 5, it'll ask if 5 equals 5. 5 equals 5 registers a true, and then if true, well, by the nature of the if statement, we know that if whatever is inside is true, then the code inside is going to run. And so, by our predictions, x equals y. And so that means that this must have evaluated to true. So that's about all there is for that equals. So these are comparative operators. So these compare things. You basically take two numbers, you'll have two sides to your little expression here, and you'll get a true or false. Return true or false. So these comparative operators return a true or false based on the integer or double or kind of number values that are around these. And they make sense just kind of as they would in normal mathematics. Now, here are going to be some logical operators. Something like an AND. So I'm going to change y to 7. And what I want this to do is I only want the inside code to run if x equals 5 and y equals 7. Okay, so there's only one condition in which this will happen. Here's our first condition, x being equal to 5. And note that we still use this double equal sign because we're asking to get a Boolean value, a true or false, based on whether or not x is equal to 5. And x has already been set to 5. So 5 equal to 5? Yes, that's true. But now we're going to introduce, well, I'll just write AND here first, which isn't actually the syntax, but just kind of to visually see it first. X is equal to 5, and y double equals 7, which would also return a true or false. The syntax for the AND in Java is the ampersand sign twice. So it's on the 7 of your keypad up top after you hit Shift. Something that you don't really use much except in coding. And so this basically reads, if x is equal to 5 and y is equal to 7, then do whatever is in here. And so if only one or the other, or neither, are true, then this will not run. The only condition in which this will return a true is if both of the arguments on the left and right hand side are true. And we suspect that that will be the case, since these do match up as we've told it to. So let's run that. X equals 5 and y equals 7. But if I change one of these, and say 6, 6 equals 5, false. So there's no way this can run because one of these is false. And I ran it and nothing happened. If I change the other one as well, nothing happens. There's only one condition in which this can run. Only one set of numbers, x and y, for which that will return true, and that's when x is 5 and y is 7. So that is the use of the AND with two double equals operators. But let's see here. You could also use it with any of these operators. So you could say x is greater than 5 and y is greater than 7. Since instead of to keep changing this, I'm going to say the conditions were met. So we'll see printed out the conditions were met if this evaluates to true. So is x greater than 5? No, it is not, because 5 is not greater than 5. It's greater than or equal to 5, but it's not greater than 5. And the same with 7. 7 is not greater than 7. So both of these will evaluate to false. So then false and false, that's not going to be a true, because you have to have true and true in order for the whole thing to be evaluated as true. So no conditions met. But if I say x is equal to 10 and y is equal to 12, 10 is greater than 5 and 12 is greater than 7. So we see that the conditions... Oh, whoops. My bad. I should have been changing the other guys. 10 and 12. So 10 is greater than 5 and 12 is greater than 7. And we see that the conditions were in fact met. And so that's that. You can combine these. I don't actually think I've seen this before, or I don't think I've done this before yet, but int can be negative as well. You could set x equal to negative 10. And so what I'll do is I'll set one of these like negative and one of them positive. And I'll say that x has to be greater than 0 and y has to be less than 0, which essentially means x has to be positive and y has to be negative. Right now it's the opposite case though, so we shouldn't get anything when we run it, which we don't. But if I flip these around and I run it, the conditions were met because 10 is greater than 0 and negative 12 is less than 0. And both of those are true. So that is the case. So, and. The other one that we're going to look at is the OR statement. The OR statement. So we want to see that one of them is true or the other one is true. And this particular OR actually will return true if both of them are true as well. So I'll go back to single evaluations. So let's say that x is 5, y is 8, and we're going to look at an OR. So only return true, only print out the conditions were met if x is equal to 5 or y is equal to 8, let's say. And the actual syntax for an OR is a double pipe character. You have to hit shift and it's underneath your backspace and you use 2 of them. It's another one of those characters that you might not have ever used in your life before. But it is, reasonably common in programming. And so I'll add that to our family down here. And so I'll change this to a 10 though. So now I'm saying only print this out if x is equal to 5 or y is equal to 10. But we no longer require both, only one of them. So y is not equal to 10. This will register as a false. But this will be a true, and that's good enough. And so if I run this, we will see that the conditions were met. But if I change this guy too, to say a 6, x is not equal to 6 because 5 is not equal to 6, and y is not equal to 10 because 8 is not equal to 10. Neither of those are true. And so that or that is false. Neither of them are true, and the conditions are not met. So what's powerful about this is that you can sort of, branch out things. And so if you just wanted to take say a single integer, another technique about comments is that if there's something you want to kind of ignore for a while, if there are some lines of code you just want to pretend don't exist for a little bit, you can just put your cursor in front of it and do that double slash so you can comment it. So this effectively doesn't exist anymore. But if I want it back, I can just do that instead of retyping it. So let's say we're going to do a little test for 5. And we want that 5 to be either greater than 10 is greater than 10, or x is less than negative 10. And so you've got all your integers, and it can be really, really negative and really, really positive, but there's kind of like a no-fly zone in the middle of these guys. And so you only want to say that the conditions are true if x is greater than 10, or if x is less than negative 10. So can x be 5? It's not greater than 10. It's not less than negative 10. So no, it can't be 5. X isn't in those zones. And if we run that, we confirm that. But if I make this 11, we do get it, because 11 is greater than 10. So one of those conditions are met. Even though this one's not, we only need one. Or let's say negative 11. In which case, this condition will be met, because negative 11 is less than negative 10. This one's not true, but that's okay, because the OR only requires that one of the conditions is met. So we run that, and the conditions are met. And so you can see that you can use that to kind of make these zones. The other thing you can do, I'll go back to the AND again for a sec, just as a final example. If x is greater than negative 10, or x is less than 10. And so in this case, instead of kind of having a no-fly zone in the middle towards 0 and having everything else be okay, now only things that are between negative 10 and 10 are valid. And so we have this zone that's okay between negative 10 and 10, so it's like a 20 wide zone, and then everything to the left or far right of that is a no-fly zone. And I need to make this match here. So if x is less than 10, or x is greater than negative 10, so now I require the number is between negative 10 and 10. Negative 11 is not anymore, as confirmed by no message gen here. But if I put in negative 9, then it is. If I put in negative 7 or negative 6, it is. If I put in 0, it is, because 0 is both greater than 10, both greater than negative 10 and less than 10. So there's that, and we can go all the way up to 9. And that is met because 9 is less than 10, but still greater than negative 10. And so what we can really do is create these zones where things are valid. maybe starting to finally think about slightly real world applications. You know, maybe you have to fill out some application for some sort of program that you want to apply to, and you have to put in the year that you were born in. And for whatever reason, or maybe they want to check if you're a senior citizen, and so they can say, if you were born in any year that was less than this year, then you can receive this. But if you were born any year greater than this, then you receive this. Or even better yet, let's say there was a discount, and the same discount either went to children under the age of 10 or people over the age of 65. And so you could say, if your age is less than 10, or if your age is over 65, then you get that discount price. Otherwise, you have the regular price. And so these situations where you can either join things together and give this range that's connected, or these two branching ranges with an OR statement, they're both highly applicable to real life, and constantly throughout programming you'll have to set them up and be aware of what sorts of ranges you want your numbers to be in order for them to meet certain conditions that you want. And I think that is going to wrap up this video, and so that essentially covers the logical operators that'll need to be met, except one of them, which is the not, but that is fairly straightforward. And so in the next video, I will be covering information about the not statement, or the negation operator, as well as introducing what is known as the else statement, which basically says if this is not met, then we can specify a kind of backup plan for our program to execute so that we don't have to check opposing conditions every time we run something. So I hope that was informative, and I look forward to seeing anybody in the next video.